Hello. All of you, good afternoon. This is Maruti Prasad Sir. Hello. Hi, hello. This is Maruti Prasad. Hello. Hi, Trilok Sai. Good afternoon. Welcome to Unacademy YouTube channel. Thank you. Thanks for coming, Trilok Sai. Please stay with us till the end of the session, okay? Hi. Once again, I am saying that this is Maruti and I have more than 13 years of experience in teaching chemistry for EAMCET, JEE as well as NEET students. And please subscribe this Unacademy YouTube channel, like it and share it. And before I am starting it, I want to mention a small thing about the plus subscription of Unacademy platform. If you are a subscriber, then there is no problem. If you are not taking any subscription, please take the subscription immediately. Okay. Yes, there are so many number of benefits are there. The premium, we will deliver the premium content which is at affordable price, and structured live courses will also be there. And after completion of the live course, we will start the live doubt clearing sessions also. Okay, so many number of quizzes at regular intervals for getting self analysis of yourself, and the badges for complete preparation of the syllabus. We have test series for daily practice papers and full length mock tests with complete analysis are also there. And by taking single subscription, you will get unlimited access. It is a promo slide, just it's a promo slide. Don't get left anyone. And see, you can utilize 20 plus top educators, 10 plus batches, 250 plus courses, 2000 plus lessons, etc. Okay, Maruti Live is my code. Once you are applying my code, you will get 10% of instant discount. Right? And this is another important plan. The best plans for EAMCET 2021 aspirants are 12 months plan and 6 months plan. 12 months plan is 12,375, whereas 6 months plan is for 10,125 rupees. It is 1000 approximately and it is 1600 approximately. Okay, and multiple batches will be launching every month. Every month different multiple batches will be launching. And Maruti Live is my code. Once you are applying my code, you will get 10% of instant discount. And as I mentioned earlier, two comprehensive batches has been already going on. One is for 6 months, second one is for 8 months. It is physics, chemistry and biology, and it is for physics, chemistry and mathematics. Okay. And the last one, it is Telugu batch. Telugu batch kuda manaku launch chesaru. You can learn from the best educators for EAMCET 2021, and I felt very happy as one of the educators out of these 4. And detailed explanation in Telugu language for better understanding of all the learners. Complete syllabus coverage will also be there, and wherever necessary we are giving the tips as well as tricks to time save as well as for better score. For the price and 2250 rupees for 1 month trial plan it is, and it has been already ఇంకా రిలీజ్ అయినట్లేదు కదా. 2021 డేట్ ఇంకా రిలీజ్ అవ్వలేదు. త్రిలోక్ సాయి ఇంకా ఏది రిలీజ్ అవ్వలేదు కదా. ఇప్పుడు either ఏప్రిల్ ఆర్ ఏప్రిల్ ఎండింగ్ అని చెప్పారు, కానీ ఎప్పుడు అన్నది we don't know. Okay, త్రిలోక్ సాయి, right? So this Telugu batch has already been started on 12th of October. Maruti Live is my code. Once you are applying my code, you will get 10% of instant discount. Right? Now let us start our important topic, that is 60A group elements. We will discuss about the 60A group elements right now. ఒకసారి చూడండి, జాగ్రత్తగా అబ్జర్వ్ వినేస్తే 60A group elements 4 సెషన్స్ లో కంప్లీట్ అయిపోతుంది మనకి. What are 60A group elements? Trilok, do you know? Trilok, do you know? Anyone please tell me. What are 60A group elements? Oxygen, sulfur, selenium, tellurium and polonium. These are all 60A group elements, right? You are utilizing 60A group elements and now let us start the atomic numbers. Oxygen is 8, whereas sulfur is 16. Sulfur is 16. Selenium, if you don't know the atomic number of selenium, simply you have to add the 18 to this sulfur. Then you will get 34. Okay. And after that, if you don't know about the atomic number of tellurium, again you have to add 18 to it. Then you will get 52. What about the polonium? 32 you need to add. So 84 is the atomic number. 84 is the atomic number for us. Right? And what about the general electronic configuration? General electronic configuration oxygen kada, oxygen ఎలా రాస్తాం 1s2 2s2 2p4 1s2 2s2 2p4 మరి సల్ఫర్ అయితే 3s2 3p4 for selenium 4s2 4p4 and it is 5s2 5p4 and the last one it is 6s2 6p4. So the general electronic configuration is looking like this. General electronic configurations ఇలా కనిపిస్తాయి. So ఇప్పుడు outermost, these are all outermost electronic configuration. If you generalize it, then you will get ns2 np4. ns2 np4 is the general outermost electronic configuration for the 6a group elements. Okay. So polonium ki nenu ikkada star pettanu. Why I have written the star on the polonium? Because polonium is a radioactive element. Polonium is radioactive element. That's why I have placed the star on this. Okay, right. So what about the occurrence or abundance? What about the occurrence or abundance of all these 6a group elements? If you observe the occurrence or abundance, how it will be? Let us discuss. So generally oxygens will be occurred as oxides. Oxygens will be occurred as oxides and sulfur can be occurred as either sulfides or either sulfates. Okay, so the abundance of the sulfur can be done either in sulfides or sulfates. ఈ రెండు రకాల్లో ఎలా అయినా దొరుకుతుంది అన్నమాట మనకి సల్ఫర్ అనేది. ఓకే రైట్, థ్యాంక్ యూ. Oxygen can be occurred in oxides. Oxides la kanipistundi. See, the minerals of sulfur I am going to discuss right now. Minerals or ores of sulfur. Ela dorukutundi? I am observing the sulfides first. Just observe the sulfides and after that you have to see the sulfates. You have to observe the sulfides first. Then we will go to sulfates. Sulfides ki evaina konni raddam. Galena. Okay. Zinc blend, copper pyrites, like that. Galena means lead sulfide, PbS. Zinc blend means zinc sulfide. Copper pyrites means CuFeS2. It is copper pyrites. So these are all the ores of or minerals of sulfur. Minerals or ores of sulfur. Adi kuda elanti ores? Sulfide ores. These are all sulfide ores. Coming to the sulfate ores. సల్ఫేట్ ఊర్స్ కొద్దాం ఒకసారి. యా, జిప్సమ్ ఫార్ములా అందరికీ ఐడియా ఉంది. CaSO4 2H2O, it is called gypsum. And if you take the epsom means magnesium sulfate heptahydrate, MgSO4 7H2O is called as epsom. And in the same way barytis, BaSO4, barium sulfate is called as barytis. So these two are the ores or minerals of the sulfur in the form of sulfides or in the form of sulfates. Okay, so out of all these elements like oxygen, sulfur, selenium, tellurium and polonium, which will be abundant mostly, which will be occurred mostly in the Earth's crust means oxygen can be occurred mostly, then sulfur, then selenium, and the least abundant element is tellurium in the 6a group elements. So in the 6a group elements, the foremost element which is occurred in the nature is oxygen, then sulfur, then selenium and finally tellurium. Okay, right. And see, one important concept I want to discuss here is preparation of oxygen. Preparation of oxygen. How do you prepare the oxygen? ఆక్సిజన్ ఎలా ప్రిపేర్ చేస్తారు? In the laboratory, how do you prepare, and in the maximum, that means in large scale, how can you prepare? Let us see. In the laboratory, you can prepare by two methods. One is decomposition of potassium chlorate in the presence of manganese dioxide. In the presence of manganese dioxide, if you heat it, if you decompose it, then 2KClO3 will be produced, 2KCl plus 3O2. Okay, 3O2. So potassium chlorate ni potassium chloride oxygen కింద separate చేసేయచ్చు మనం. And in the same way, KMnO4, potassium permanganate can be heated, then it will produce K2MnO4 plus MnO2 plus oxygen will be separated out. So in this way, you can prepare the oxygen in which method? In laboratory method. Lab లో ఇలా prepare చేసేసుకోవచ్చు మనం. Okay. And on large scale, if you want to prepare, the oxygen, then you have to do the electrolysis process. ఎవరికి చేయాలి? Electrolysis of water. Water and electrolysis చేసాం అనుకోండి, then you will get hydrogen as well as oxygen. So you can easily get the oxygen by doing the electrolysis of water. If you want to get the large scale of oxygen, ఎక్కువ ఆక్సిజన్ కావాలి అంటే ఇలా చేసుకోవచ్చు మనం. Okay. Or otherwise, one more important technique is also there, that is you can obtain the oxygen by its respective oxides. So oxides ni heat chesam anukondi, mercurous oxide is produce the oxygen with mercury, and lead oxide, if you take the lead oxide, from the lead oxide also you can get the oxygen, and from silver oxide also you can get the oxygen. From hydrogen peroxide also, hydrogen peroxide, from hydrogen peroxide also you will get the oxygen. So you can prepare the oxygen in so many number of methods. ఎలా కావాలంటే అలా ప్రిపేర్ చేసుకోవచ్చు మనం ఆక్సిజన్ ని. Okay, these are all the important methods for us to prepare the oxygen. And coming to the chemical properties of oxygen right now. Chemical properties of oxygen. Oxygen can react with phosphorus, and that means it is non-metal. Phosphorus is non-metal. So oxygen can react with non-metals. Oxygen can react with metals also. Oxygen can react with organic compounds. Oxygen can react with some of the metal sulfides. Oxygen can react with acids. Oxygen can react with sulfur dioxide also. ఇన్ని రకాల properties మనకు ఆక్సిజన్ కు ఉన్నాయి. So many number of properties are there. So when the phosphorus reacts with oxygen, it will produce phosphorus pentoxide, P4O10 will be produced. And when the aluminum reacts with oxygen, it will produce Al2O3. When the methane reacts with oxygen, it will produce carbon dioxide and H2O. It is a combustion reaction. It is a combustion reaction. అంటే ఒక ఆర్గానిక్ కాంపౌండ్ ఆక్సిజన్ ప్రెసెన్స్ లో బర్న్ చేస్తే carbon dioxide, water along with some amount of energy will be produced, along with heat energy will be produced. Okay, so zinc sulfide ni gaani manam if you react it with oxygen, then it will produce zinc oxide will be produced. In the same way, oxygen can react with HCl also. So 4HCl plus O2. In the presence of copper chloride, you will get chlorine gas plus 2H2O. Chlorine gas will be produced when the oxygen reacts with HCl. In the same way, sulfur dioxide 2SO2 plus O2 gives rise to 2SO3. This is very important equation for us. 2SO2 plus O2 gives rise to 2SO3. So you can get you can react the oxygen with all these important substances. So inni rakaluga మనం react చేసుకోవచ్చు అన్నమాట. Then how can you get the sulfur? Oxygen అయిపోయింది కదా. Next, preparation of sulfur. How can you get the sulfur? Let us see the preparation of sulfur now. Yeah, okay, thank you. Thank you, Buji. How can you prepare the sulfur? Yes, 3FeS2 gives rise to Fe3S4 plus sulfur. See here, sulfur will be produced by the reacting of iron sulfide. And in the same way, hydrogen from hydrogen sulfide నుంచి కూడా మనం sulfur ని produce చేసుకోవచ్చు by reacting it with sulfur dioxide. Okay, 3S will be produced and 2H2O will be separated out. Here also you can get the sulfur. So sulfur ని ఇలా మనం తెచ్చుకోవచ్చు అని అంటున్నాం. Okay, is it clear? Right, very good. Coming to the next one. ఆక్సిజన్ సల్ఫరే మనకి ఇంపార్టెంట్. ఆక్సిజన్ సల్ఫర్ రెండు కూడా మనకి ఇంపార్టెంట్ అనమాట. అయితే ఇందులో ఇంకా సల్ఫర్ సెలీనియం టెలూరియం అక్కర్లేదు. పొలోనియం చూసారనుకోండి, దిస్ పొలోనియం కెన్ బి అబ్టైన్డ్ బై a molecule like pitch blend U3O8. U3O8 is a radioactive element. Once you react it, so you can easily isolate the polonium from the uranium oxide, that is U3O8. U3O8 నుంచి ఐసోలేట్ చేసుకోవచ్చు అనమాట మనం పొలోనియం ని. దట్స్ ఆల్. ఇంకొకటి మనం ప్రాపర్టీస్కి వచ్చేద్దాం. జనరల్ ప్రాపర్టీస్. Let us see the general properties of the individual elements. ఒక్కొక్క దాంతో జనరల్ ప్రాపర్టీకి వద్దాం. The first important property we are observing is here. Very simple, that is atomic radius. Oxygen to sulfur, sulfur to selenium, selenium to tellurium, and tellurium to polonium. Slowly the atomic size will be increases from top to bottom in the group of 6A. So 6A lo from top to bottom వెళ్ళేసరికి then the atomic radius will be increases as the orbits will be increases. Orbits increase అవుతున్నాయి కదా, అందుకని అలా జరుగుతుంది. And just observe the physical states. Physical states observe చేద్దాం. If you take oxygen, sulfur, selenium, tellurium and polonium, physical states observe చేస్తే oxygen is only the gas at room temperature, whereas remaining all are other elements are solids. Remaining all are solids, but oxygen is a gas, but remaining all are solids, right? And we will observe the metallic state. What about the metallic state from top to bottom? Oxygen, sulfur, selenium, tellurium and polonium. Polonium is a pure metal, but selenium and telluriums are metalloids. What is the meaning of metalloid? It consists both metallic nature and non-metallic nature. Metallic nature, non-metallic nature రెండు ఉంటాయి. ఉంటే దాన్ని metalloid అని పిలుస్తాం. ఓకే, రైట్. ఉంటే దాన్ని మెటలాయిడ్ అని పిలుస్తాం. ఆక్సిజన్ అండ్ సల్ఫర్, దీస్ టూ ఆర్ నాన్ మెటల్స్. Oxygen and sulfur are non-metals, whereas selenium and telluriums are metalloids, and polonium is a pure metal. Even though it is a radioactive element, it is a pure metal అన్నమాట మనకి. And coming to ionization potentials. Ionization potential ఒకసారి అబ్జర్వ్ చేద్దాం. 6A గ్రూప్ ఎలిమెంట్స్ అబ్జర్వ్ చేస్తున్నాం మనం. ఆక్సిజన్, సల్ఫర్, సెలీనియం, టెలూరియం అండ్ పొలోనియం. అవుటర్ మోస్ట్ ఎలక్ట్రాన్స్ ఎలా ఉంటాయి? NS2 NP4 అంటున్నాం కదా. సో NS2 అండ్ NP4 1 2 3 and 4. So how many number of electrons are present here? 2 number of electrons are there కదా. అందుకే ఈ 2 electrons ని మనం లాస్ చేయాలి. సో ఫస్ట్ ఎలక్ట్రాన్ లాస్ చేస్తున్నాం, ఫస్ట్ అయనైజేషన్ ఎనర్జీ. సెకండ్ ఎలక్ట్రాన్ లాస్ చేస్తున్నాం, సెకండ్ అయనైజేషన్ ఎనర్జీ. సో వెన్ యూ ఆర్ మూవింగ్ ఫ్రమ్ టాప్ టు బాటమ్, వాట్ అబౌట్ ద అయనైజేషన్ ఎనర్జీస్? Ionization energies will be decreases when you are moving from top to bottom. Okay, అంటే దీనికంటూ ఒక స్పెషల్ అయనైజేషన్ ఎనర్జీ will be there. But if you observe 5th A group elements and 7th A group elements. If you compare the ionization energies of 6th A group elements with 5th A and 7th A, ఈ రెండిటితో కంపేర్ చేశారనుకోండి, 5th A group elements ఎలా ఉంటాయి? NS2 NP3. So it is full-filled, it is half-filled. It is fulfilled and it is half-filled. So it is more stable. Once it is more stable, what about the ionization energy? Ionization energy is very high for 5th A group elements compared with 6th A. And what about the ionization energy of 7th A? 7th A ఎలా ఉంటాయి? NS2 NP5. NS2 NP5. So here the nuclear charge is very high. Here the nuclear charge is very high. So once the nuclear charge is very high, obviously the ionization energies are also very high. So for the 5th A group elements, ionization energy is high. For 7th A group elements also, the ionization energy is high. So what about this? 5th A, 6th A and 7th A. Immediately observe చేస్తే 5th A is having more ionization energy than 6th A because it is more stable. And 6th A తో కంపేర్ చేస్తే 7th A is having more ionization energy because it is having high nuclear charge. That's all. న్యూక్లియర్ ఛార్జ్ ఎక్కువ ఉండటం వల్ల దీనికి అయనైజేషన్ ఎనర్జీస్ అనేవి ఎక్కువగా ఉన్నాయి అని అంటున్నాం. And coming to the next one, that is electron affinity. Electron affinity. The order of electron affinity is looking like this: sulfur, selenium, tellurium, and the least one is oxygen. So ఎందుకు oxygen కి electron affinity బాగా తగ్గిపోయింది? Why the oxygen is having very least electron affinity? Because oxygen is having very compact in nature. The atomic size is very less and the total molecule is compact in nature. Total atom is compact in nature. That's why electron affinity is very less compared with sulfur, selenium and tellurium. That's all. And the next one is, next property is atomicity. Oxygen, sulfur, selenium, tellurium and polonium. Oxygen is diatomic molecule. Oxygen is a diatomic molecule, but sulfur, selenium, telluriums are octaatomic molecule, whereas polonium is monoatomic molecule. అంటే ఆక్సిజన్ రాయాలంటే ఎలా రాస్తాం? O2 అని రాయాలి. సల్ఫర్, సెలీనియం, టెలూరియంలు S8, Se8, Te8 అలా రాస్తాం. Okay. Then after that, polonium రాయాలంటే it's only a single element. Of course, it is a radioactive element. So these are all the atomicity. So why the oxygen is having diatomic molecule, but sulfur, selenium, telluriums are octaatomic molecules? Oxygen లోనే atomicity ఎందుకు అలా వచ్చింది అని అంటే, because if you observe the structure of oxygen, Z equal state, ఒకసారి స్ట్రక్చర్ చూడండి, 1s2 2s2 2p4 కదా, 2s2 2p4 means 1 2 3 and 4. Okay, so here this oxygen will not participate in the hybridization and the oxygen molecule will be formed only by the overlapping of this py as well as pz orbitals. Py pz orbitals overlapping వల్లనే మనకి ఇందులో ఆక్సిజన్ మాలిక్యూల్ ప్రొడ్యూస్ అవటం జరుగుతుంది. చూద్దాం. సపోజ్ ఇఫ్ యు టేక్ వన్ ఆక్సిజన్, ఒక ఆక్సిజన్ తీసుకుంటున్నా నేను, ఇట్ ఈస్ వన్ p orbital, it is the other p orbital. So this py, it is py, it is pz, or otherwise if it is pz and it is py, it is pz but it is py. Again one more oxygen, py and pz. So py and pz, it is pz whereas it is py. It is belongs to one oxygen, it is belongs to other oxygen. See here, in between these two one sigma bond will be produced and in between these two one pi bond will be produced. Andukane you can write it as O double bond O అని రాస్తాం. O double bond O, because because oxygen is having one sigma bond and one pi bond. This pi bond will be formed with the help of p pi p pi, with the help of two p orbitals in the oxygen. In one oxygen one p orbital, in other oxygen one more important p orbital will combine together and forms pi pi bond will be produced. So ఎప్పుడైతే ఇలా వస్తుందో ఆక్సిజన్ is having a capacity to form O2. O2 ని ప్రొడ్యూస్ చేస్తుంది, but sulfur does not having this type of capacity because oxygen is having very less atomic size, whereas sulfur is having highest atomic size. So the pi bonds will breaks up in the sulfur, so sulfur is forming only S8 means only sigma bonds will be produced. So ఎలా S8 ని ప్రొడ్యూస్ చేస్తుందంటే, this S8 can be produced, S8 can be formed either in two structures. One is called puckered ring, or simply it is called crown shape. This puckered ring is called as chair shape. So sulfur can be not S8, of course it is S6, it is S8, and it is S6. So sulfur can be shaped, or sulfur can be structured either by these two rings, crown shape ring and chair type shape will be there for S6. So how the S8 shape will be there? S8, okay, 1 2 3 4 5 6 7 and 8. So total there are 8 number of sulfurs we have. So these 8 sulfurs will form a crown shaped structure or puckered ring structure. There is a puckered ring or crown shaped structure. In the same way, S6 also. How the S6 will be there? This is the first one, second one, third, fourth, fifth one, sixth. That's all. 1 2 3 4 5 and 6. So it is looks like a chair. It looks like a chair. Okay, this is S6 structure and it is S8 structure. And if you observe the bond angles for S8, it is 105 degrees and the bond length is 2.05 angstrom units. 2.05 angstrom units. And what about the bond angle here? It is only 102 degrees and it is 2.06 angstrom units. The bond length is 2.06 here, and here the bond length is 2.05 angstrom units, but the bond angle is 105 here, the bond angle is 102 here. Okay, very good, nice. Coming to the next one, that is allotropy. Very important. Allotropy, what is the meaning of allotropy? Allotropy means the element is same, but the physical forms are different. Element is same, but the physical forms are different. Suppose if you take oxygen and sulfur, oxygen can have only one allotrope, that is ozone. The chemical formula is O3. But sulfur can have two different types of allotropes. One is rhombic sulfur and the second one is monoclinic sulfur. Rhombic sulfur and monoclinic sulfur. These two are the allotropes of sulfur. But ozone, oxygen is having only one type of allotrope, that is ozone. Okay, here you can convert rhombic sulfur to monoclinic sulfur or monoclinic sulfur to rhombic sulfur. So you can convert either from this. Rhombic to monoclinic you can convert, or monoclinic to rhombic you can convert. At what temperature it will convert the rhombic to monoclinic? and monoclinic to rhombic, that is 95.6 degrees Celsius. Very important it is. 95.6 degrees Celsius. At this temperature only, rhombic sulfur is converts to monoclinic and monoclinic sulfur is converts to rhombic sulfur. So below which it is more stable and above which it is more stable. At 95.6 degrees Celsius, both the sulfurs will be stable. This temperature is called as transition temperature. This temperature is called as transition temperature. What is the meaning of transition temperature? In the transition temperature at 95.6 degrees Celsius, then what will happen? Rhombic sulfurs are converts to monoclinic or monoclinic sulfurs are converts to rhombic sulfur. So that particular temperature is called as transition temperature. That's all. Up to this our allotropes of oxygen and sulfur are over, and tomorrow or in the next session we will discuss about the complete details about the allotrope of sulfur. Okay, until then keep watching my videos. Thank you. Bye.